All right, looks like most everybody is here now, and that's what'll be on the final exam. Any questions? Just kidding. All right, let's go ahead and get started. Hi, everybody. How are you all doing today? Good. A couple of things. Since the projector is brighter, I'm going to leave the classroom lights on today, so hopefully you'll be awake more. The other thing is I finally made it to the store, and I bought a giant bag of Rolos. Who needs a Rolo? Who else needs Rolos? Oh my god, I don't even know if I have that many. But I'll throw some more out during the class. Now that the lights are on, I can actually see where everybody is, so it'll work better now. Before we go any further, you should be working on the code for your project now. Does anybody have any questions? Yes, ma'am. How do you do spacing? You put a C out with an end line. We'll talk about a little bit about that today. So we're like a day behind. So today I'm going to like compress a whole bunch of stuff you need to know into one day, and then we'll revisit in a little bit more detail, which is horribly inefficient to do it, but we're stuck. So yes. So the question is, how many input checks should you have? And the answer is all of them that you need to make sure that people don't do crazy things. When you check your input, you should check for range errors, but not for type errors, which means that if you give somebody the opportunity to enter an integer, I can guarantee you they're not going to enter a letter. I promise you that, because we haven't learned how to fix that yet. But you should make sure that their values are reasonable. So for example, if somebody asks for the number of refugees, can they have a negative number of refugees? No, they cannot. Can they have a negative number of water sources? No. So the range checking should, I mean, there's not that much stuff to enter, quite honestly, so the range checking should be reasonable. Let's see. Yes, sir. If you have a big error in your algorithm, then fix it in your program, right? It's like that's like asking me if you have an error in the draft of your paper, can you revise the draft? Of course you can. Absolutely. And the point of doing the algorithm early is so that you had some time to think about it, so you had a chance to correct those. So feel free. We're not going to go back and compare your program against your algorithm to make sure that they're the same. That was just to force you to do an algorithm. Sir.
So you said we don't need to have type checks.
Nope.
They try to put in 23.5.
Yep. If your program crashes, we will not hold you accountable for that. So, yeah. Right now, we are not going to give you type errors, okay? And in fact, throughout the semester, we're not going to give you type errors. C++ input has its good things, but it has its bad things, and dealing with type error is one of the bad things, and so we're just not going to deal with it. We'll pretend it doesn't exist. Other questions? Yes? Yeah. So if you're expecting an integer, we're not going to give you anything that has letters or anything that has numbers. We might give you negative numbers. We might give you big numbers or small numbers or zeros, but we're not going to give you negative numbers. Okay. Other questions? Yes? So, our philosophy for keeping the grading simple is if you're outside of the range, just have your program stop. My sample program, which I tried to explain before, is not the perfect program, just one I kind of drew as a sketch for making the assignment, just gives you a warning. But yeah, it's very common for programs to throw error messages or not accept output outside a certain range. Huh, well, you can come to my office hours and we can figure out why or see a TA. So, and it's entirely possible, by the way, that my program has bugs in it. In fact, it's expected that my program has bugs in it. Yeah. In my one I gave you, I just threw a warning, and it says, warning, you're doing something other round, you can keep going. I would prefer for your program and for grading, you should make it stop. Okay? So, yes? Mm-hmm. Yep. Yep. Well, I mean, I use that exact chart, and I use the liters per minute. And if you read the fine print there, the assumption is that they get 8 hours of use per day for the tap. Sure. Okay. So the question is the website gives you a certain number, and it gives you a number in liters per minute. And the question was, for your own use, can you just do the math and convert that to hecto kilo acres per day or whatever you want to work in, right? And the answer is you can, but the answer is also you shouldn't. And here's why. Say that they go along and they do another study and they realize that they had the value of the amount of water that comes out taps wrong. And instead of being 7.5 liters a minute, it's actually 8.2. Does that make sense? So say they make that discovery that they had the wrong number. To change your program, we would have to go look at the code and figure out that magic number that you mathematically converted, and then figure out what that was and change it. It would be easiest in your program if you had a constant up at the top that said tap liters per minute equals 7.5 or whatever the number is. And that way, if we realize we're wrong, we just change it in one place. The computer is exceptionally, incredibly good at doing math, way better than you are, way better than all of us put together in the room are. So let it do the math, right? Just plug in that number and tell it how to convert to the units you need. And that way, if anything changes, we just change that one number and your whole program changes. So I recommend against doing the conversions yourself. Let the computer do them. Yep. Yep. Sure. Sure. Or you can do something like minutes per day equals 60 times 60 times 24, right? Or 60 times 24. I did seconds. Sorry about that. 60 times 24. You can just put something in there. Minutes per day equals 60 times 24. That's unlikely to change, but the computer can do 60 times 24 in a picosecond, right? Like faster than we can even express the idea. So just let it do the math. And then other people later on, when they look at that number, they can go, oh, there's a variable named seconds per day, and it's 60 times 24, and that's correct, right? If I told you there's 3,600 seconds in a day, am I right or not? I'm not sure either. But I can look, and I can say it's 60 times 24, right? The computer can do that math in an instant. So let it do the math, and then just people can understand by looking at what you're doing, what's going on. Yes? It's a bad example, yeah. Yeah. hmm Your program, if you get up to large numbers, will automatically go into scientific notation. We will learn about, for the next project, how to format the output in a particular way that we want. We just haven't got there yet. Sir? hmm So the question is, if inside the if statement you end the program, like with a return, the else statement is not needed, you do not always need an else statement. No, it's good form. If you're going to end the program, there's no point in having an else statement, because as you go along, if the program ends, you're never going to get down to the lines of code before. And that's the example I gave in class last time. I think I did it that way. It's the better way to do it. So one more thing. I have the video. I'm converting the video. I forgot to put it up last week of last class. But halfway through the class, my microphone battery died, and so the sound just disappears on the video, which kind of sucks. If you all notice that like the sound goes away overhead at some point, let me know, because I'm busy talking. I have an extra battery. I'll pop it in, and then we'll have the sound for you to listen to. So there's like all the stuff from the last videos there, but there's only half the sound. Okay, let's see where we are. Oh, come on. We're going to do the projector thing again? Okay, ready? Okay. Any last questions? Going once? Yes? It's better to create a named constant. So create a named constant that's like hours, 2 days, and then you can set it equal to 24 times 30 times whatever, and it will do that math before it sets the constant. And then when people read your code, it's better. it's almost always better, and I won't say always, but it's almost always better to have named constants and to do the math algorithmically. So when people read their code, they will see the named constant and understand what it is, instead of seeing a number and not necessarily having the context for that number. For our program right now, it's very small, and if I put a number times, if I just have something in there that's 24, what am I referring to? Well, how do you know? Right? How do you know there's not some sort of special well that the double well that produces 24 liters per minute, right? So we assume we infer a lot from numbers, but it can actually be misleading. If you have a program that has a lot of different stuff, it's much better to have named constants so it's explicit about what you're talking about instead of just having numbers. Also, if something changes, you only ever have to change one place, that constant declaration at the top, and then the rest of the program's taken care of. Okay. Everybody good with that? All right, so last time, we've been talking about algorithms. What's an algorithm? Wait. Who wants to tell me what an algorithm is for a Rollo? Yes, sir. I don't know, what do you think? Judges? An ordered series of steps used to perform some task, close enough. Who wants to tell me what a program is? A program, yes? Judges, an algorithm expressed in a form a computer can understand, a human can execute. Do we give it to her? All right. All right. Do you all think these are important? So last time we talked a little bit more about data types. We talked about bool. What does a bool represent? True or false, which is really not 0 or 0. 0 is, not 0 is 1 not 0? Is A not 0? Okay. Is 0 not 0? No, 0 is 0. Okay. All right, we talked about floats. What do floating point numbers hold? And what's the problem with floating point numbers? Representation error, right? We have this problem that we're representing decimal numbers as essentially as the sum of a series of fractions, and we may not be able to add all the fractions up to get exactly where we want. That's representation error. Over the time we do math and we get what kind of error? Rounding error, yeah. We talked about char. What's a char? And how does it work? There's a numeric code for each letter. We talked about the ASCII. We use ASCII in this class, but there's also something else. Anybody remember the other one? UTF, yeah, that's what you should be using in the future. Okay, then we got into a little bit of error checking, and I addressed some questions about this, right? Error checking for our programs, we're only going to check the range of values. We're not going to check the type. And we talked about, this is checking ranges for reasonableness, and we talked about stopping the program if things are out of range. How do you stop your program if you want it to stop? Return 0. You can put that anywhere in the code, and when it hits that, it will just finish right away. All right. At the end of class, as I was rushing through, we talked about a few additional types. Anybody remember one of the additional types we talked about? Yes? A what? Here you go. What's a double? And what does it hold? What type in there? Here you go. Oops, sorry. Okay. So we talked about a double, which was 2 little boxes. We talked about a long double, which is 4 boxes. This just gives you more bits in memory to have these little fractions that we're adding together, so it gives you better representation. A double is 2 memory boxes, a long double is 4. Okay. For ints, what did we talk about for ints? We talked about a long int, which is 2 boxes. Long ints are very, very big. You probably never have to use them in your life. I don't know that I ever have. And we talked about one other that we were just finishing up. What was the other one? Unsigned int. And so the idea of an unsigned int is this. Let's just go back briefly and look at how we've been representing these numbers. Is this starting to look familiar here? So I just copy the same slide over every single time, right? We have 2 to 0, 1, 2, 3, 4, 5. Whatever number we represent is a sum of these powers. And the example we've been using is that we have, a 2, an 8, and a 16, and they add up to 26. This is essentially what an unsigned int is. The smallest number we can make in this is 0, and the biggest number we can make is the sum of 32, 16, 8, 4, 2, and 1, which should be 64. Okay? Maybe 63. I'm going to go with 63. Okay, so we can represent 0 to 63 with these bits. Question is, how do we do negative? Yes? I'll talk about that briefly, okay, in just a second. So here we have, we can represent numbers here from 0 to 63. Does that make sense? 0 to 63. What happens if we want a negative number? Because we do have negative numbers, right? How do we do negative numbers if we have a signed int, which is int is by default? What we end up doing, in essence, is we end up taking one of these bits and just using it to represent whether it's plus or minus. So before we could do 0 to 63. Now we have fewer bits, right? We can only do 16 plus 8 plus 2, plus 4 plus 2 plus 1, which should range from 0 to 31, right? It's really 32. Now, this is actually a lie. This isn't how we do it. We do it a different way, but conceptually this is what we're going on. When you have something that's signed, you give up a little bit of your range in order to have the plus and minus ability. Does that make sense? So before we could do from 0 to 63, now we can do essentially minus 32 up to 32.
You said that the int is just signed.
Yes, by default an int is this, unsigned, but a signed int is what we were talking about when we talk about math, right? So by default, the binary numbers we've been talking about have been unsigned, but in reality they're signed and they have a little bit of plus minus going on. Okay? This is just a concept. Again, the computer doesn't do this, it does something else, but conceptually this is what we're doing. So the difference between a signed int is you get minus some number to a number, in this case like minus 32 to 32. An unsigned int, you get 0 to 2 of whatever it is, right? 0 to 2x. And the formula for this comes down to the number of bits. Like an unsigned int on our computers that are 64-bit computers is essentially minus 2 to the 63rd to 2 to the 63rd minus 1. That's the range of numbers it can represent. So a signed int on our computers that are 64-bit is a big number. An unsigned int is 0 to 2 to the 64 minus 1. Anybody know what 2 to the 64 is? It's a big number. Anybody know how many squares there are on a chessboard? Anybody ever heard the fable? There's a fable, I believe it's an Indian fable of origin, where a wise man goes and he asks for his reward, and he goes, well, put 1 grain of rice on the first square and then 2 on the second, and it doubles every time. That is 2 to the 64. It is a huge number. In fact, it's so huge, let's look at how huge they are. Signed int runs from minus, 100,000 million, billion, trillion, quadrillion, quintillion. Did I get those back? Minus 9 quintillion to 2 positive 9 quintillion. That's a 64-bit integer. That would be a lot of rice. And a signed int runs up to like 18 quintillion. So we have pretty big numbers to work with these days. Not like when I was a kid, we only had 32-bit numbers. So, all right. So in general, the question was, when do we use these things? In general, for almost everything you do, an int will be sufficient, unless you're dealing with numbers that are bigger than 9 quintillion. That's a really big number. I've never had to use something bigger. For floats, in general, I would suggest using doubles almost all the time. And the reason is that floats don't have enough accuracy, and we run into the limits of accuracy just in like everyday use. All right, everybody good with this? That's everything we need to know about types. Sir? Sure. Because if you have, if you have 4 bits, you can represent 2 to the 4th values, but 0 ends up being one of those values, so you take 1 off there, because you have to count for 0 as well. Does that make sense? That's why the minus 1 is here, because 0 takes up one of those spaces. All right. All right, how's everybody doing? So what we were doing last time then is I had just talked about, some of these other things. There's one more thing you might see, which is an unsigned char. and this is used in a special case that we won't encounter in this class, where if you want to keep track of individual bits and you want to be able to set and change individual bits without treating it as a number, people often use an unsigned char for this. You probably won't run into this. I'm just mentioning it. You'll never remember when you do find it because I'm not mentioning it very fast. I probably shouldn't mention it, but it exists. All right, everybody good? So rule of thumb, use an int for ints, use a double for floats. You'll probably be good. Use a character for character, use a bool for bool. Bool is true if it's, and it's false if it's, okay. All right, so that's enough about types. Let me ask you a math question. Where are my math majors? Anybody? A few of you, okay. Let's say we do something like this. We declare a variable named x, and then we set x equal to some math operation. And here's what it's going to be. It's going to be 5 minus 2 times 2 plus the square root of 16. I got to give myself the math library because I forgot about that. And then we output x. Who wants to tell me what this program is going to output? 10? Yeah. 5? Have you all, I don't know how many old people, yes? -3? Okay. So, is it immediately obvious what this is going to print out? No. How many of y'all know old people on Facebook, like your parents or parents' friends? How many of you are actually still on Facebook? Oh my God, I have to sell my stock. I don't have any. So, like a month or two ago, there was this thing going around where there were like math problems, and they'll be like, you'll be shocked at the answer to this simple math problem, right? And it was all about this, is that what is the correct order to do these operations, right? What is the correct order to do these operations? Pardon? PEMDOT, is that what you? Okay, well I have a different one for you. You get to learn something new. Let's just go ahead and see what this outputs though while we're at it. All right, gosh, please let me have fixed my compiler. Woo, okay. All right, so bets, some people had -3, negative number. Some people had 5, who thinks it's 5. Some people had 10, who thinks it's 10. Some people, how of you have never done math before, so this is a good learning experience for you. All right, so the answer is it's going to print out 5 this way, 5. And the question is, why does it print out 5? And the reason is because there is a particular order of operations that goes on when we do math. And here's what it comes down to. It goes like this. It goes first, parentheses, then functions. Oh, have you programmed before? Because you're actually right about exponents, but C++ doesn't have exponents. So, yeah, but you all don't have functions. See, you're learning new something. And then where does it go from here? And these, and the add and subtract, these two things, they both go left to right. Is that correct? Yeah, left to right. So this is the order in which we do things. So the order in which these things are evaluated is first, are there any parentheses in here? Well, there are, but they're part of the function. So really the function gets evaluated first. So the square root of 16 is 5? What? 4. Okay, so the square root of 16 is 4. So we have 5 minus 2 times 2 plus 4. So what happens next? 2 times 2. So 5 minus 4 plus 4 is, it's like 9, right? Nice. My kindergartner is learning to add and subtract, so I do problems like this all the time and give him the answer. And he's always very upset when I give him the wrong answer, so it's kind of fun. So it ends up being 5. Now, if we wanted to change it, if we wanted to change the order of operations and do something like put parentheses around here, what would happen in this case? Yeah, this would output 10 just because we changed the order of operations, and now we get 10. Now, let me just say something about this. I do not recommend when you do math this way. And the reason is that the computer is very good at evaluating it, but people are bad at remembering these rules. Aren't they? Yes? Absolutely. So here, I would recommend doing it a different way. And what I'm going to do is I'm going to create another folder, another file. And here's how I would actually do this math. If I wanted it to go in a particular way, I would do something like this. I would say x equals square root of 16. I would say x gets assigned to itself plus whatever's next, right? Like whatever operation you want to do next. The next one we'd be doing would be like 4, right? X minus 4 plus 4. Just trying to make sure I'm doing this the right way. Did I get that right? Let's just. So I'm trying to get back to our original answer of 5. That can't be right then. Oh, that's right. X equals 5. Got it. That's what I get for winging it. All right. This is why I recommend not doing it this way. I mean, what I normally do is I have a multi-step computation as I break it down somehow, and I should have done a better example here. But we can do one of two things. We can either force a particular evaluation by putting parentheses around everything. Does this make sense? So now what we're going to do is we're going to have to evaluate the function first. We'll evaluate the parentheses, and then the parentheses get evaluated from inside out, and they force a particular ordering of the operation. All right, everybody kind of good with this? So you have to know this because sometimes you run into it. I may or may not put it on the exam. I tend not to write questions about it, but it's something you need to know. I really suggest when you do math that you put parentheses around it to force it to evaluate in the order you want, or to write it out line by line, which I didn't do a very good job of here. Questions on this? Pretty straightforward, right? Everybody happy? All right. Everybody stand up for a minute. I've been talking for 26 minutes straight. I'll have a 1-minute break. Ready, set, go. All right, welcome back. Any questions come up to you during your minute of rest? Yes? No? All right, moving on, we're going to quickly touch on something we've already done quite a bit of, but I just want to make sure that we cover it. This is how do we do output? How do we do output? Cout. So if we want to output something, say we have int x and we set this to some value 5 and we want to cout something, we have this angle-angle operator. And the way the angle-angle operator works is it works from left to right, and everything that appears between these, essentially, I think of it gets shoved into these. I like to think of these as a funnel, right? It's a little funnel, and you take whatever's in and you shove it into the funnel, and whatever appears in the funnel ends up on the screen. Does that make sense? So I can say the answer is okay. So here's what we have. We have the answer is X, and which is good, and the end of line. So if we compile this, we're going to see something that we don't like. And what's that we don't like? Okay, we didn't put a space between the 5 and which. So for output, right now, what we have to do in order to format output is just manually put some spaces around to make room for things. Later, probably like next class, if we don't get to it today, I'll show you a better way to format numbers. Okay, so you don't just always have to space things out directly. But everybody good with this? You've probably done this in your own program so far, right? Yes, sir. Uh-huh. You cannot have line breaks. I don't believe you can have line breaks between the quotes. So I don't think you can put a line break on the quote. I believe that will probably fail. Yeah. But you can have like breaks outside the quotes. So you can put things. So, you know, again, white space doesn't really matter. We can kind of do whatever we want in terms of that. Sometimes some people like to do output like this. You know, I kind of put mine. I tend to only break mine up when I need to. But there's just different ways of doing it. And what does the ENDL do? Yeah, it makes it wrap around to the next line. So if we got rid of this, for example, and we had another line down here, right? And we compiled that, we'd see that you know, the line wrap didn't happen automatically. That we don't have any space in between good and because I didn't put any space between them, right? If I put a ENDL here, then we will get a line break between those two, which is probably what we wanted. So I put an ENDL in there, and now we have a thing in there. But I'm also missing an ENDL after the 8, so my output's ugly again. Yes? Oh, that's my computer name. Like when you log into your computer, it says CS class. This computer is named Fear. Because I didn't have an inline right here. I was just going to show you that. See that one right there? What happened is the program finished, but it didn't put the end of line to push it down to the next line. So my command prompt, which is this thing I can type commands at, ended up right after the program output, which is ugly, right? So how do we fix it? Where do I put it? At the end down here? No? Where? There? Okay. The other thing you can do is if you want to space things out multiple times, you can put multiple end lines there. So if you want to give your program a little bit of vertical space between them, you can just, you know, put multiple lines there. Is that better? Yes? Because you don't have to have an end line. An end line is just there to help you with the formatting. It is not required. It is not required at all. The program will let you format your output however badly you like or however well you like. You are in charge. So sometimes you want the end line. Sometimes if you're piecing things together for output, you don't use the end line. Everybody good on that? It's pretty simple. We've been doing it for a while. I just wanted to make sure that we touched on it a little bit more formally. All right. Now we can do some even better stuff. All right, so we have output. We like output. What's even better than output? Input. Why is input good? Because your program sucks if you don't have input. It's only going to ever do one thing, right? Every time you run it, it's going to do exactly the same thing because you're not taking any input. It's just going to do it. And that programs that only do one thing are typically very boring. Anybody ever played a game where you didn't have any input? You just sat and watched it? It's called a movie, right? Movies suck. So, all right, so input. We need pound IOStream, just like we always did. But now what we're going to have is we can have different types. And I'm going to switch from floats to double. Just to get you in the habit of using doubles. So we can have like an int, a float, we can have a character. What else do we have? Bool. Let's not worry about bools. Bools do input everything else. It's false if the input is 0. It's false if it's 0. And anything else is not true. I can show that to you later if you want. All right. So let's look at some input now. So we can do something like cin into integer, into decimal, into character. Okay. And then we can output those things when we're done. All right, so what is this? This is our program. The program is an expression of an algorithm. What does our algorithm here do? Yep, declares some variables, inputs 3 numbers, outputs them again. Should we go ahead and run this? Yes? Here? Yeah, I know. I did that on purpose. All these, this is, CHR is a 3-character abbreviation for character, and I just wanted them all to line up nicely. So, yes? Well, let's see. Let's see what happens here. So, let's make sure this compiles first. Input.cc-o input, not overwrite it. All right, it compiles cleanly. That's good. And we run it, and what happens? It's waiting for our input, but how do we know what input it's waiting for? We have to output something first. So we've covered this briefly. Your program is probably not doing the right thing unless it instructs the user on what to input, right? Okay. So we're going to give the user a prompt so that they know what to input. Programs that just sit there and blink the cursor at you, waiting for you to psychically guess what's going on, could be awesome if you were psychic. But if you're psychic, then you shouldn't go into computer programming. You should do something else. Okay. I have a feeling you have a great future ahead of you. All right, so let's compile that. That works. Now when we run it, it says, please enter an int, a float, and a character. Is that good? Yes? Okay. We'll see in a minute. We'll get to that, okay? So let's just make sure this works. Somebody tell me an integer. What? 28. A float. 7.7. And a character. At. All right, so we output. It was 28, decimal was 7.7, character was at. We're happy, right? How many of y'all are happy? Why are you not happy? Because it's sloppy. Yeah. All right, so let's go in here. And what we'll do to fix this is we'll just put some spaces here. Or we can put end lines. Do you want them all on their own line? Which do you prefer? All right, your own lines. So. All right, so this should be a lot nicer. We'll compile this. Screen, we'll run it. And int, we did what, 8 last time, 7.7 at. And we're happy. Everybody good? All right, I'm going to make a small edit to my program. You know what I'm going to do? I'm going to change the order of these things a little bit. I'm going to have it I'm going to have it read the integer first, then the decimal, then the character. I'm sorry, integer, then character, then the decimal. I should have done it that way first, but I got ahead of myself. All right, so I just changed the order a little bit. Let's run it and make sure I didn't break anything while I was doing that. All right, an int. I did break something, didn't I? All right, that seems to be better. Let's stop that. We'll compile it again, run it again, and now we'll run it and see what happens. An int, a character, and a float. Okay, who has an int for me? 23,000. Has a character? Q. And a float? 17.85. Woo! Okay. Did that work? All right. Does that kind of answer your question? Now, let me show you something about CN. CN is your friend. CN is your friend who wants to help you as best it can get input from the user. So let's say that we have a user who isn't very good at typing spaces. And they say, oh, well, I'm inputting 23,000 Q and 17.85. What is going to happen here? So, is it going to try and think that whole thing is an int? Why not? It's all mashed together. The first thing looks like it's an int. What's it going to do? All right. CN is going to do its very best to figure out the right input for you. Okay? It's going to try very hard to figure out the right input for you. So what it's going to do is it's going to look at this and go, oh, I'm starting here. What is the biggest integer I can take out of that input? 23,000, because Q cannot be an integer, right? And then it goes, okay, I've read the integer. I have to find a character. What is the character I can take for this? It's going to go, well, Q is a character, and then it's going to look for a float. And what's the biggest float it can take for that? So, if we run this, we get exactly what we got before. Exactly what we got before, because in this particular case, in this specific case, it was able to figure out that this was the biggest integer, the 23,000 was the biggest integer it could take. The Q was the character it could take, and the 17.85 was the float. Okay. Yes, sir? Yeah, I switched it around because you couldn't put a float after the integer. I forgot. Yes? Let's try that in a sec. See. Yes? Yep. No. There is a way to specifically input hexadecimal. We're not going to learn it in this class. I can tell you separately. I've done class projects in the past where I taught you that. It's pretty easy. It's just we don't need it, so I'm not going to bother with it right now. All right. So the question then becomes, what happens in other cases? Like in that particular case, we entered 23,000 Q, 17.85 or whatever it was. It was able to figure out what happens if we do like something like we just enter 7.7 right now. What's going to happen? Everybody see what I'm doing here? I'm trying to explain how CN works. And what CN does is it looks at the type and it tries at any point to get the longest type it can for you. So, starting from here, we know we have an int, a character, and float. What is the largest integer you can take off the front of the input working from left to right? What is the next thing that follows that? A point. Is a point a legitimate character? Yes, it is. And then after the point, what number is next? Is that a float? It sure can be. So what we end up here is it says int was 7, character was point, and float was 7. CN tries its hardest to do the right thing for you. It tries really hard. Sometimes it does the right thing, right? Like here, maybe somebody was trying to enter 7.7 and it got the wrong thing. But this is what CN does. It tries to do the right thing. And what ends up happening is everything that's read gets put into one of these variables, right? So cin first reads an integer and it puts it into the int variable, integer. It then reads a character, it puts it into the char type character, and then it reads the double and puts it into decimal. Everybody with me on this? It's pretty straightforward so far. How many of y'all are with me? How many of y'all are against me? Normally one smartass in the class, but not today. Okay. All right, so everybody good on this? Now I want to show you for a fact that what's happening is cin is overwriting these values. Okay? So I didn't initialize these variables before. Yes? I do. Thank you. Sorry. I got to get the range on that back in there. Okay. So now we're going to give these things some initial values. So what I'm going to do is I'm going to cut and paste this code right here so we can actually see that those values are set before we do anything else. Okay. Everybody with me? So now what we're going to do is I'm just going to run this program again so we can kind of see the difference. So it compiles cleanly. We like that. And then when we run it, it says, okay, here's what I've got. An int that's 1, 2, 3, a character that's an @ sign, and a decimal number that is a poor approximation of pi. So let's go ahead and enter some stuff. Somebody give me your favorite integer. 12. We'll do 34 next time. What's your favorite character? Bang. I like bang too. All right, and then a decimal number. 2.1. And when we run this, we see that int was 12, character was bang. So we had a number in there before, and we changed them. Everybody good with this? Straightforward so far? You wondering where I'm going with this? You getting bored yet? How are you all doing? Okay. Well, I'm just going to assume if you're not science, silence is complacency or assent or whatever you want to do. All right. Any questions so far? All right. So here's what we learned. You can use cin. It will always take the biggest piece it can for you, unless it sees a space. Cin breaks on spaces. It will automatically separate things by spaces if there are spaces in there. Yes? So there's a difference between this input, 12 bang 2.1, right? This works because cin tries to figure out the biggest things it can take. But if you put spaces in there, it works exactly the same, except cin doesn't have to figure out things for you. And it will automatically break up the input based on the spaces, or tabs, or returns. Yeah?
What would happen if you put the float first? Would it still find the greatest integer first?
Okay. So the question is, what happens if it puts the float first? And I'm about to demonstrate some of the stuff that happens. That's weird. So let's say we go ahead and we run it, and we're going to enter an integer. What's somebody's favorite integer? 16. I stole you a 34. Sorry. My favorite character is a parenthesis, and I hit enter. What happened? Yeah, it stopped, and it said, oh, okay, I found an integer and I found a character, but I'm expecting a float also. So I'm going to ignore that return. In fact, I'm going to reward a whole bunch of returns, and I'm going to ignore a bunch of spaces until I get that float you promised me. And once I get that float you promised me, then it'll work. Okay? So cin ignores white space, and it breaks up input on white space. If things are jammed together, which they should not be, I'm just telling you this is a weird behavior that you can run into, things will happen. And if you don't give it everything you want, it'll just sit there and wait for it. So if you're ever running a program and it's just sitting there waiting for something, and you don't know what, it probably might be waiting for input that it hasn't gotten yet. Everybody good so far? All right. cin is your friend. Everybody say after me, cin is your friend. It is going to do its best to help you with output, but there's something you need to know about cin. It's a good friend. It tries really hard, but cin is a quitter. All right? cin is going to quit on you sometimes, and when it quits on you, it's not going to say anything. It's just not going to show up. Okay? Anybody ever moved? Have you ever had your friend help you move? You arrange all your friends to help you move boxes, and then on moving day, your friend just doesn't show up, and you have to do it all yourself, and they don't give you an explanation? That would suck. Anyway, I don't know why I said that. But CN kind of is the same way. And let me show you where CN does things. So here we are. We have an int. What's the value of the int right now? 1, 2, 3. We have a character. What's the value of the character? The @ sign. We have a decimal. What's the value of the decimal? 3.14. Okay, now let's say we asked for an int, a character, a float, and we enter A1392. What's going on here? Something bad is going to happen. All right, and here's what's bad. Remember, I promised you, and you keep asking me, what happens if you enter the wrong type for a program? Is A an integer? How many of y'all think A is an integer? How many of you think it's not? Okay, so here's what happens. When CN gets a type error, that is when it gets the wrong kind of thing, it quits. And here's what's going to happen. When I run this, I'm going to get the exact same, oh man. I'm going to get exactly the same things because CN quit on us. Here's what happened. CN looked and it said, I'm expecting an integer, and I got a character. So it goes, I'm just going to make that integer 0. I'm done. Right? And then it stops reading any of the other input. It doesn't read anything after that. So we put a 14 and a 92 there. It did nothing with them. It threw them out the window and went home. Seriously, right? The values that we had before, the @ and the 3.14, are still there. It didn't change them. It just said, I'm going to leave those exactly the way they are. So CN is your friend. It will attempt to get as much input for you as it can. But if it gets a type error, and when it quits, it never works again. Never in the same program does it work again. Never. It just quits, and it stops working for the entire program. I'll show you. Yes? Yes. Even if you put into other CN statements, here, we'll just break this down. CN, it's not just for that statement. Once CN quits, it quits for the rest of your program. So instead of just having one CN statement, now we have 3. And it's going to be exactly the same as it was before. The same thing is going to happen if we give it a type error. So we'll compile it. It still compiles. We'll run it. We'll give it a type error, E. And then even if we give it correct stuff after that, somebody name your favorite character. Period. And a floating point number. 0.1. It quit. CN saw this E, it was expecting an integer, and it goes, if you give me an E when I'm expecting an integer, my honor is impugned. I quit. How could you do this to me? I am leaving. And no more input happens. Essentially what happens is every other input line in the program, if we look at it, is skipped. So here's what happened, is we tried to read a character into this integer, and it said, I quit. So we get to this C, and then it goes, hey, I'm done. I'm not doing any more input. We get to this C and it goes, I'm still done. I'm not doing any more input. And then output stuff. No. So just like if it's waiting for input, if you give it too much input, it just goes through and gets it at once. Yeah. So anyway, so CN is your friend who will go out of their way to help you if something is messed up, but then quit and never show up again the moment something goes wrong. Everybody see where I'm coming from here? Everybody sort of got it? Am I speaking English today? Oh, okay. So, questions about CN and its wonderful, helpful quitting ways. Sir? The input will never work again once you have a type error. Never. Even if we change this around. If we say, even if we split this into 3, here's what's going to happen. We say enter an int, enter a character, enter a float. Fix that for us English majors there. Okay. So I've split it into 3 separate things. I compile it. It compiles well. I run it. Tell me your favorite int. I like G2. There you go. Every other CN statement just quit. It quits. So remember in your program I told you that we would never give you a type error? This is why. Because if you have a type error in your input, CN quits and it becomes problematic for you to deal with. Now, how many of y'all think there's a way to fix this? There is a way to fix this. There is a way to check and see if the type was wrong and fix it if it was. How many of y'all want to learn that? No, you cannot learn that. All right, you can, and it's in the book probably, but here's the deal. In our programs, trying to fix something that's gone wrong is too complicated for what we're going to be doing right now. Okay? It's too complicated. Later in the semester, if you really want, I can show you how to fix things. But right now, I want to make it easier on you. Yes, sir? No. No. Right now, we're just going to pretend that type errors don't exist. Okay? Have you all ever heard of a type error? Well, they're just a fairy tale. They don't really exist. So, all right? Everybody see where we're coming from. Now, I almost always on the exam, on the midterm, have a question about input, and I almost always put a type error in there to see if you know what happens when CN gets a type error. Any reason to suspect I won't do that this semester? Nope. Pardon? Can I just, yeah. All right. So that's CN. Everybody sort of happy with CN? CN is your best friend who will quit the moment something goes wrong. All right. So take a 1-minute break in place. Stand up. Don't put your computer on the floor, though. Because it scares me. I have this because I might step on it, or somebody coming up from behind will step on it. It's a sin to put your computer on the floor. It's a sin. Yes. Sorry. I mean, you can put it there if you want. It's just I'm going to stand there and be terrified and stare at it the whole time, going, "Yeah, yeah, you're a saint." It says right on your shirt. So. All right, welcome back. There's one more thing we need to go over briefly so that you'll have all the pieces that you really need to finish up your program. We're actually making good progress today. I'm psyched. I didn't expect to do the stuff about CN breaking today, but we're ahead, so why not? Okay, so the one other thing that we need for this project is to do switching, which is an if statement. And we talked about if statements before. They look like this. We have if, we have some parentheses, we have some curly brackets like this. What goes inside this parentheses? Yes, sir. A what? A condition. And what is this type? What type is this condition? Anyone to guess? Yes, sir. A boolean. Yes. So we always have this. Our if statements always look like this. We have if, a parentheses, some boolean expression, and I put this little angle brackets to represent something that can be changed. And then we have some other code. The easiest way to always do other code is to have like a curly bracket at the end and another curly bracket, and then you can put what's on the inside there. All right. Now, we've been talking about booleans, type bool. They have two values, false, which is, and true, which is. Okay, so let's put some stuff in here and actually test if this is right. Here's what we're going to do. We're going to put an output statement and say cout was true. And others are going to have an else, and we're going to say cout was false. All right, so let's put something in this parenthesis. How about 0? So here's our algorithm. If 0 cout was true, else cout was false, return 0. What is this going to print out? Was false. Anybody think something different? How many of y'all think it'll be was false? How many think it'll be was true? How many of you have no opinion on the subject? How many are you willing to have your mind set by demonstration? How many of you are suffering from arm injuries? Apparently this side of the class. All right. So here's what we'll do. We'll compile this. It's okay. Sorry. Okay. It wouldn't have made any difference. So, and when I run this, what's this going to print out? Was false. So, we had code, and we just put a 0 in there. 0 is always great. Now, what happens if I put a P in there? Okay, first of all, it's not going to compile because we don't know what P is. But if I put it in quotes so that it's a character, literal, it will compile. And is it going to be true or false? Why? Because it's not 0. How about if I put a 0 inside there? Is it going to be true or false? Why is it going to be true? Okay, it was true. And the reason it's it's true in this case is because since it's inside the single quotes, it is a character. And we know about characters, they are represented by a code number. And when we do this, it's looking at the code number for 0, which I said the other day, and I forgot what it was. It's like 32 is space. That's all I remember. Yeah. Yes. Yeah, but it's hard to get that character because it's a weird control character. So, okay. Everybody with me so far? So let's try some other stuff here. Let's say, how about 3 less than 5? Is 3 less than 5? Do you think this is going to print out true or false? True. Let's try it and see. 3 is less than 5. We can also do greater than. So I'm going to put some of these up here. We have less than. You might have seen this somewhere before. We have this one, which is greater than. Is 3 greater than 5? For very large values of 3, it might be, but in general, it's not. So you can do greater than, you can do less than. We've seen equals, right? So we can do something like int x equals 5, and then down here we can do x equals 5 to compare. Is this going to be true or false? Okay, what I'm doing here is one of the most common errors in the C language. What am I doing wrong here? All right, 1 equals is, and 2 equals is. When I put 1 equals here, here's what happens. It changes the value of x from whatever it was before to, and then it says x is, so the whole thing inside the parentheses is 5 true or false? Yeah, it's true. So this is going to print out true. Now, what we wanted it to print out true. Let me just change this a little bit. So now if I have x equals 3 and I compare it with 5, this is going to be true or false. Okay. So let's just prove that for the good of mankind. It was false. Okay. So 3 is not equal to 5. But if we forget one equals sign, what's going to happen? It's going to be true and, whoa, let's see. Oh, look at that. That's awesome. So one of the cool things about compilers is that from time to time they change the compiler. And since the last time I taught this class last semester and did this lecture, they have changed the compiler to alert you that you are likely making a mistake, which is awesome. Let's all give a big round of applause for the compiler designers. So this is awesome. I did not expect this. All right. Well, this used to be a super common error until the compiler designers fixed it by fixing the compiler. So, all right. So that can go wrong often, but it won't anymore. All right. So we have less than. We have equal. Anybody know how to do not equal? We talked about that. Bang, equal. So we can say x not equal 5. Is 3 not equal to 5? Yes. So this whole thing will be true. If we compile it, 3 is not equal to 5 is true. Okay. The thing about not is you can do another thing too. You can put the not in front of the thing. So bang equals means not equal, but bang by itself means not. And not will flip the value that returns there. So if we have bang x equals 5, so is 3 equal to 5? Yes or no? But if we put a bang in front of it, what happens? It flips it. So let's just see if the compiler people are allowing this these days. Yeah, they are not. They are, so we have to put the whole thing inside parentheses. You used to not have to do that. I suspected that once they made that change, they'd change the other thing. Okay, so we compile it. And here's what we have. If not x equals 5, x is actually, is 3 equals 5? So no, but we flip it and it becomes true. So now when we run it, it should be true. Okay. The other thing we have is we can compare and check multiple things at the same time. So, for example, say we wanted to have another variable named y, which was 12. If we wanted to check and see if x was 5 and y was 12, we could do it. Yes, sir? It's easier to, no, you don't, but I always do it this way because it's easier to read. Okay? This undergoes the same precedence we talked about before. You do the parentheses first and then the and. So. All right. So what value does x have? Is 3 equal to 5? What value does y have? Is 12 equal to 12? Okay. So we have no and yes. What is the answer? False. Okay. So this whole thing should be false. So it was false. So ampersand is and. And is true only if both are true. But we also have or. Anybody want to tell me about or? It's true if either are true. And it's false only if both are false. Yes, sir? The vertical bar is it's the key just above your return key. It's that vertical bar, yeah. Yes, sir. There is no bang ampersand, but you can put a not in front of anything. So there's not. These are essentially all the Boolean operators we have right here, except for 2. Yeah. So I mean, you can do like this, right? So you can get some pretty complicated logic, and there's a whole thing called Boolean algebra that we could get into about how to do this stuff, but we don't want to do that. We just want to be able to do basic things. Okay. Yes? You can, and in fact, let's do that. Let me just show you a couple things, and then we'll do a bool variable. Okay. Two things I forgot. I forgot to do that and this. What are these? Yeah. All right. I'm going to tell you something that I am bad at, and I want your help catching it as we go through the semester. When I'm doing less than and greater than signs, about 94% of the time I put them the wrong way. It's just the way I don't do it well. So as I'm going over the course of the semester, if you see me put the greater than or less than sign the wrong way, you can just go ahead and tell me. I will not be insulted. I know I'm bad at it. So it's like the most common bug I write into my programs. It's horrible. Because I always stop and I know I'm bad at it, and I think about it very hard, and then I do it the wrong way. So, okay. So we have and, we have or. So the question we had is, can we store some of these things as a Boolean value? And the answer is absolutely. So we can do something like bool value. And we can set value equal to any result that we've seen before. So we can do something like this. So, bool holds what? So we declare a variable that holds a value true or false. It can only be true or false. So we can use these Boolean operators to determine whether things are true or false. And we can store that in a variable that holds whether it's true or false. So this gets set to value equals means we're assigning value equal to is x, whether x is equal to 5 and y is equal to 12. So what value is going to be put in the variable named value? It's false. What's x? What's y? Is 3 equal to 5? Is 12 equal to 12? So only one of the two parts of the and are true. Therefore, the whole thing is false. So this is like a standard, if you become more computer sciencey and take more programming classes over time, this is the standard thing. You know, somebody will ask you, do you want coffee or tea? And you'll say yes, because you want one, and because or if one or the other, then they're both true anyway. You'll see, you're groaning now, but I guarantee you, if you keep doing computer science, you will find a day where you will say that. And you'll think back, and you'll not actually remember this conversation. But anyway, you'll probably do it someday. Yes? It does not know. Can you ask your question again?
Yeah, it doesn't really make sense, I guess, my question. But why does, if the value is true, why does it know to output true as opposed to knowing that it's
Okay, so here, okay, sorry, I went through this pretty fast because we had a lot to cover and I was hoping to get through this today. Here's the deal. When you have an if statement, it will only do the thing that's in the if statement if this Boolean expression is true. Okay? Remember, the computer is just a big, fast, dumb machine. It does one step after another. The way we write these steps are from top down. So it's steps. It gets to this if, and it says, if it's true, I'm going to do the next step. But if it's not, I'm going to go to whatever is after the end of the curly bracket. So the only way it knows to print out what's true is because I gave it the instruction saying output true of true, so that we could have a little bit of space to experiment with. Does that make sense? We don't have to output is true here. We could do something here. We could put something like if that instead of is true, we could put like erase the hard drive. We could do some computation, unleash the worm, fire nuclear missiles, like whatever it is, right? Whatever algorithmic step you want to do there. But I was just trying to demonstrate how the if statement and Boolean statements work. Sir? Sure, you can do that. If we wanted to do something like, well, we haven't set Q, and so it's kind of undefined what Q is going to be. So you're going to get unpredictable behavior. Oh, you can do that, yeah. Well, it ends up, right now X is going to be less than the character Q. And only reason I know that is because I know the character Q is like up in the 50s of that code table. Yeah. Yeah. Mm-hmm. Yes. Now, honestly, you're never going to do that, right? The whole point of me showing you there's a code number behind is just to be able to explain when some weird stuff happens. We're not going to go around comparing integers and characters and floats and stuff like that. We're just not. Not in this class. Okay. All right. Everybody feel that they can like go out and do useful things with if statements? How many of you have already written your code that has if statements in it? All right, good. Ah, awesome. Round of applause for starting early. I'm psyched. That's great. Great. Go finish your code. Good luck. We'll come back on Thursday, and then, I don't know, we'll do nuclear missile launch instructions or something.